Hello everybody, welcome to AS Engineering Academy and AS online platform. The AS Engineering Academy is providing online courses for almost all engineering students in almost all aspects. That means it may be any exam for engineering students, or it may be GATE, or it may be GENCO, or it may be engineering services. Any exam, the AS Engineering Academy is providing the online courses. Now, coming to myself, so I am Prasad Meghavarna and I am dealing you the power systems in the AS Engineering Academy. And I have 12 years of experience in teaching, particularly in power systems for GATE and engineering students. Right? Now, coming to my study, so I have done my MTech in 2010 and I am presently pursuing my PhD in the SU University, Tirupati. Now, I am saying here, welcome to the world of power systems, so that we have to learn a lot of things, and the syllabus of power system is very, very important. Particularly in this class, we are going to discuss about the transmission and distribution of electrical energy. In the transmission and distribution of electrical energy, so we'll take one important concept, which is voltage control and power factor correction. So we'll see some basic details about voltage control and power factor correction in this session. So here, so we are going to discuss voltage control and power factor correction. The first question everybody can raise, what is that? Why we need voltage control? So what is the purpose of voltage control, right? See here, so coming to the first question, why we need voltage control? Why voltage control is required? So why voltage should be controlled? Why voltage should be controlled? That is the first question, right? Why we need voltage control? And we have specified the voltage control or the voltage limits at every bus is nothing but, so the voltage limits are the voltage limits at every bus that are specified are 0.95 per unit less than or equivalent to voltage at that particular bus is less than or equivalent to 1.05 per unit. Therefore, the voltage at every bus should be maintained between 0.95 to 1.05. What happens if we are unable to maintain these limits? That we have to study. Clearly see here, students. Whenever voltages are more than that of, the rated voltage. Suppose if it is the maximum voltage, V maximum, and this is the minimum voltage, V minimum. Clear? Whenever the load is experiencing voltage which is more than that of the rated voltage of the system, at that particular condition, the insulation of the load can be damaged. Clear, everybody? Please here, we know the insulation level of every element is always proportional to the voltage level. The insulation level is always proportional to voltage level. Particularly speaking, highest voltage level. Therefore, whenever you are getting over voltage or voltage which are more than that of the rated voltage of that load, at that particular condition, the insulation of the load can be damaged. And whenever the insulation damages, what happens? Short circuits may occur, and because of short circuits, heavy short circuit currents will flow in the load, and because of which the load may be damaged. Therefore, whenever voltage which is operating, or whatever the voltage the load is experiencing, which is more than that of the rated voltage, what happens? Insulation will be damaged. Whenever insulation is damaged, as a result, short circuits will occur. Whenever short circuits occurs, then what happens? The short circuit currents will damage the load, right? The short circuit currents will damage the load, will damage the load or the element whatever it is experiencing over voltages. Therefore, the voltage in the system or the voltage across the load should never be more than the rated voltage. Should never be more than the rated voltage. So high voltages are always avoided. Now we are saying that the voltage should be between minimum to maximum. The maximum we are specifying, and because the insulation problem, what is the reason of specification of minimum voltage? Why we are specifying the minimum voltage in the system? We have to specify the minimum voltage in the system because, so have you seen any incandescent bulb in your homes? It glows dim sometimes, the incandescent bulb, and the TV screen starts rolling from top to bottom sometimes, and the ceiling fan it is unable to rotate at the rated speed, or even though the regulator is at 5, the fan rotates very slowly, right? We can say the reasons for these are the low voltages. Sometimes tube lights gets flickering effect. All these are the reasons of low voltage. That means whenever voltage on the power system is low, whenever the voltage at that particular bus is low, the load is unable to give whatever it requires. That means we want lighting from the bulb, we want wind from the fan. So these things we are unable to get. Clear, students? Therefore, whenever the voltage on the system is less than the rated voltage, V is less than V rated, then what happens? The load is unable to operate. The load is unable to operate, or the load is unable to give whatever it is designed for, Sometimes we are getting flickering effects also in the power system. Now check here, students. Whenever we are having low voltage, the load is not operating. Whenever we are having high voltage, the load is damaging. So that the voltage on the power system should be in the limits, specified limits. The voltage on the power system should be below V minimum, that means between V minimum and V maximum. That is why we need the voltage control. So that the voltage on the power system should be definitely controlled, and we have to maintain that voltage within the specified limits. Clear? Now, so coming to the next one, so we have seen that one, and now we'll see what are the voltage controlled methods we are having. So we are having different voltage controlled methods in the power system. First one is internal voltage control, and the second one is external voltage control. See here, students, we are having the first one, internal voltage control method. Internal voltage control method. Right. So internal voltage controlled method, we can also call this one as the excitation control method, or it is also called as excitation control method. In case of the excitation control method, so we are having, please check here, students. Whenever we are having, right? So the power system like this, for example, if this is the generator we are having, and these are the loads we are having. For example, students, we are calculating the voltage at every bus. So this is the generator bus voltage, it is always maintained constant, and wait for 1 minute, students.
Interview guidance program in EASC 2020 and EASC 2021.
Hello everyone, My name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation,
Welcome back, students. Now, you'll see, whenever you are calculating the voltages at different locations, so here it is the generator bus, its voltage is always maintained constant. So that its voltage V1 is always constant, is always constant. We know that's a PV bus or it may be a slack bus we can take. Now, coming to the remaining buses, these are the load buses. These are the load buses, and where we have connected several loads here. Here you have one load, and here you have one load, and here you have one load. For example, students, in this case, whenever we are calculating voltage at this bus V2, V3, and V4. This V2, V3, V4 should be within the specified limits. Clear? So this V2 is having its own limits, this V3 is having its own limits, and this V4 is also having its own limits. Clear, students? Now suppose we have calculated V2, it is within the limits, no problem. We have calculated V3, it is within the limits, no problem. And we have calculated V4 and we are finding some problems in the V4. Therefore, whenever we are having some problems at V4, we are going to control the sending end voltage. That is the excitation voltage we can control, right? So this generator is having the excitation, so that we are going to control the excitation of the generator. So that whenever the excitation of the generator is controlled, and we can control this voltage. Suppose V4 is less, so that we will increase the value of excitation voltage, then automatically the V4 value will be increased. Whenever V4 is more, we will reduce the excitation voltage, therefore automatically V4 will be reduced. But the problem that we are going to get in this method is, whenever excitation of generator is increased or decreased or varied, then the remaining bus voltages are also varying. That is the major problem we can face. Clear, students? Therefore, when excitation varies, the remaining bus voltage also varies. That is the disadvantage of this method. So we will take that as the disadvantage of this method. So the disadvantage of this method is, when excitation is varied, the remaining bus voltage also varies. The remaining bus voltages also varies. That is the drawback of this method. So that we are not going for this method, the internal voltage control method or the excitation control method. So this method is preferred only when all the bus voltages are varied. If required to vary all the bus voltages, then we can prefer this method. But that type of thing, so we are not having in our power system. Clear? Therefore, next thing we can go for the external voltage control method. So that is the second method we are having. That is the external voltage control method. External voltage controlled method. In this external voltage control method, we will take the same power system. So this is the generator, and we are having several buses like this. And this bus voltage is always constant V1, and we are calculating V2, V3 and V4. We are calculating V2 value, V3 value and V4 value, and V2, V3 are under safe condition. We have calculated already, they are under safe condition. And we are getting V4 value is not within the limits. Therefore, in this external voltage control method, we are going to connect some external voltage control devices at that particular bus. So wherever we are finding the voltage control or voltage problem, right? So that at that particular bus, we are going to connect the voltage control devices. So that at this bus, we are going to connect the voltage controlled buses. This is voltage controlled bus, right? What is that VCB? It is voltage controlled device, not B. It is voltage controlled devices, right? We can take it as voltage controlled device, D. Controlled device. We are going to connect at that particular bus. Clear? So that previously that may be a PQ bus. Now that bus is a voltage controlled bus. That bus is a voltage controlled bus. So previously all these buses are the load buses or PQ buses. So this is a PQ bus and this is also a PQ bus. This is also a PQ bus. Now after connecting the voltage controlled device, we are going to call that bus as the voltage controlled bus. Voltage controlled bus. So the name of this bus is VCB. What is VCB? Voltage controlled bus. Voltage controlled bus. Clear? So that this is the external voltage control method. Internal voltage control method and external voltage control method. Now we'll see what are the equations required. What are the equations required to control the voltage? Clear everybody? Now we'll see the what are the equations required to control the voltage in the system. Just look at this one. We'll consider a simple 2-bus power system network. So here we are having the generator and here we are having the load bus. This is the load we are having. The load requires a complex power demand of SD is equivalent to PD plus J times of QD. That is the total complex power demand of the load. And the generator is supplying total complex power of SS is PS plus J times of QS. PS plus J times of QS is the complex power supplied by the generator. And this is the line. This line is having complex power losses. Complex power losses. What are those? P loss plus J times of Q loss. J times of Q loss. Therefore, the generator has to supply an active power of the active power demand of the consumer plus active power loss in the system. Active power loss in the system. Along with that, the generator has to supply a reactive power demand of the consumer QD plus reactive power loss in the system. So these two has to be supplied by the generator. And we are calling this as active power supplied by the generator and this is the reactive power supplied by the generator. Clear everybody? Now check here students. We need to calculate the receiving end voltage in terms of the sending end voltage. Clear? The sending end voltage, let me write with different colors here. The sending end voltage is Vs at an angle of delta. The receiving end voltage is VR at an angle of 0. At an angle of 0. For example, or for suppose, if the current is flowing from sending end to the receiving end. Sending end to the receiving end. Now check here students. In this system, we are going to calculate the current. We are going to calculate the current in the line. So the current in the line can be calculated as, please check here. The current in the line I is equivalent to sending end voltage minus receiving end voltage. What is that? Vs at an angle of delta minus VR at an angle of 0 divided by the line impedance actually we can take. But normally we always prefer the lossless transmission lines, or we can say the active power loss in the system will be neglected. So we can say whenever active power loss is neglected, this line is not having any active power loss, and this line is having only the reactance. Suppose the line reactance is some XL, J times of XL is the line reactance we can take. Therefore, we can take the line reactance value as J times of XL, so which is nothing but Vs at an angle of delta minus Vr at an angle of 0 divided by XL at an angle of 90 degrees. That is the current flow in the line, and we can separate the terms here. So it will be Vs divided by XL at an angle of delta minus 90 minus Vr divided by XL at an angle of minus 90. At an angle of minus 90 we got here. Please check here, students. Right. Now, this is the current, and we can conjugate that one to calculate the complex power. So the conjugate of this one, it will be Vs divided by XL at an angle of 90 minus delta minus Vr divided by XL at an angle of 90. That is the current conjugate value. Now we'll calculate the complex power at the sending end. So if you see the complex power supplied by the source, the complex power supplied by the source, or by the generator. So we are calculating SS, where SS is equivalent to Vs into I conjugate. SS is equivalent to Vs into I conjugate. Therefore, where SS is equivalent to the value of Vs we have taken is, it is having a magnitude of Vs at an angle of delta into the current conjugate. So just now I have calculated the current conjugate, so which is Vs magnitude divided by XL magnitude at an angle of 90 minus delta minus Vr magnitude divided by XL magnitude at an angle of 90. Please check it. So we got Vs magnitude divided by XL magnitude at an angle of 90 minus delta minus Vr magnitude divided by XL magnitude at an angle of 90 we are having. Now we can multiply with this one. So whenever we are multiplying with this one, we will get Vs square divided by XL at an angle of 90 minus delta and plus delta will be cancelled, and minus Vs Vr divided by XL at an angle of 90 plus delta. 90 plus delta, that is the SS value we are having. And from this equation, we can calculate the total active power and the reactive power. So once the active power and reactive power are calculated from the polar term, how to calculate the active power? So the active power value P supplied is equivalent to, so Vs square divided by XL cos 90 will be 0, and Vs Vr divided by XL cos of 90 plus delta will be minus sin delta, will get Vs Vr divided by XL sin delta. Vs Vr divided by XL sin delta is the active power equation we are having. And similarly, we can calculate the reactive power also, where the reactive power supplied by the source Qs is equivalent to Vs square divided by XL sin 90 is Vs square divided by XL minus Vs Vr divided by XL sin 90 plus delta will be cos delta. Vs Vr divided by XL cos delta. And we have studied in our basics, the active power is more depending on delta and reactive power is less depending on delta variations. So from the decoupled equations we have seen, from the decoupled equations, the active power is proportional to change in delta, the reactive power is proportional to change in voltage magnitude, which means that the active power variation with respect to delta we can consider, but with respect to voltage we can neglect. The reactive power variation with respect to voltage we can consider, the reactive power variation with respect to delta we can neglect. Therefore, I am neglecting cos delta approximately is equivalent to 1. There are several reasons why, how can we neglect that delta. The delta always comes very close to 0, nearly 0.2, 0.4 like that in our practical system calculation, so that cos delta value is approximately is equivalent to 1. Therefore, cos delta is approximately is equivalent to 1. Therefore, the value of QS, we can have, which is equivalent to Vs square divided by XL minus Vs VR divided by XL. So from this we need to calculate the receiving end voltage equation. Therefore, Vs VR divided by XL is nothing but Vs square divided by XL minus QS. So now I can send XL outside and Vs also to that side. So therefore, we will get VR is equivalent to Vs minus Qs into XL divided by Vs. Right? So this is the voltage controlled equation we are having. And this is the most important equation, students. So try to remember this equation. So to control the receiving end voltage, so it will be sending end voltage minus sending end reactive power into XL divided by Vs. Now, please look at clearly. To control the receiving end voltage, we can control the Vs. That is the first method, excitation control method or internal voltage control method. So this method is not preferred. And coming to the next one, to control the receiving end voltage, we can control the reactive power supplied by the source, or we can control the reactance of the transmission line. Those are the two methods we are having. So that based on this, we are having some voltage control devices. The voltage control devices, either they are going to control the reactive power supplied by the source, or they are going to control the reactance of the line. So if you see the voltage control devices, so what you are going to have are, so the voltage control devices are going to control the reactive power or reactance of the line. Here, so that we can say it is shunt capacitor we are having. Shunt capacitor is one of the voltage control device, and shunt reactor we are having, and series capacitor we are having, and synchronous motor. In case of the synchronous motor, we are having several constructions based on the excitation. So we will be having in this synchronous condenser or capacitor, synchronous condenser we can take, and synchronous capacitor or synchronous reactor, right? Synchronous reactor, and also we will be having synchronous phase modifier. Clear? So these are the devices we are having to control. Along with this reactive power control device, we are having directly voltage control device also, like a booster transformer, by using transformer technique only. So booster transformer, and also we will be having tap changing transformer. So these are the voltage control devices we are having, students. Voltage controlled device. So in these devices, so we have to go in detail, and which device is used to increase the receiving end voltage you have to see, and we have to see which device is going to reduce the receiving end voltage, right? So at which condition we are having more over voltage at the receiving end, at which condition we are having less voltage at the receiving end, right? All those conditions we have to analyze, and we have to connect necessary, right, sufficient or the suitable devices at that particular location. Clear everybody? Now we'll see what are the problems we can face at the load side and based at which condition we have to connect which element. Clear? For example, if you are having the same two load system or two bus system, please check it. You are having a two bus system like this. This is the system consisting of the load. Now, whenever the load on the system is going to increase, the current that is flowing in the line will be increasing. Now, the line is having sending end voltage of Vs at an angle of delta, receiving end voltage of Vr at an angle of 0. The line is having a reactance of J times of XL. Clear? Now, whenever the load on the line or whenever load at the receiving end is continuously increasing, the current flowing through the transmission line is going to be increased. Therefore, we can say these terms in one sequence. So please check here. When load increases, when loading increases, whenever the loading on the line is increasing, what you are having? The impedance of the system is going to be reduced. Why? We are connecting all the loads in parallel. Whenever loads are connected in parallel, impedance will be reduced and the current supplied by the source will be increasing. Whenever current is increasing, the energy stored because of this current, what is that energy? Electromagnetic energy, right? So half Li square will be increasing. So that the energy stored by the inductor is going to be increased. Whenever half Li square is increasing, we can say electromagnetic energy is going to be increased. Whenever electromagnetic energy is increasing, as a result to that, electrostatic energy will be decreasing. Therefore, we can say the energy stored by the capacitor in the form of voltage half CV square will be reducing. The inductance and capacitance of the transmission line are always constant. Whenever current increases, electromagnetic energy increases. Whenever ESC decreases or electrostatic energy decreases, we can say voltage in the line is going to be reduced. Therefore, the voltage in the line will be reduced. So we can say the voltage in the line will be reduced. So you can say here, therefore voltage will be reduced. So that we have to connect suitable devices. To increase the receiving end voltages. Clear? Therefore, so we have to connect suitable devices to increase the receiving end voltage. Therefore, to increase the receiving end voltage, to increase the receiving end voltage, what we have to do now? We have to search the parameters. What are the parameters we are having? VR is equivalent to Vs minus Qs into XL divided by Vs. Now, as a result of, as a remedy of this problem, please check here. Whenever VR is equivalent to Vs minus Qs into XL divided by Vs, to increase this voltage, we need to reduce this term. So this term should be reduced. So that either we can reduce the line reactance, right? I will write the parameters individually here. Either we can reduce the line inductive reactance or we can reduce the reactive power supplied by the source. What are the two things we are having? we can reduce the reactive power supplied by the source, or we can reduce the reactance of the transmission line. These are the two parameters we are having. Now, whenever the reactive power supplied by the source will be reduced, whenever we are having one more parameter which can supply the reactive power. Therefore, we have to connect an element which is going to supply the reactive power. See here, therefore, whenever the element supplies the reactive power, whenever an element which is going to be connected at the receiving end, whenever it is supplying the reactive power at that particular condition, we are going to increase the receiving end voltage, or at that particular condition, the reactive power supplied by the source will be reduced. Therefore, to reduce QS, what have to connect? We have to connect a shunt capacitor. Connect a shunt capacitor. And to reduce XL more, we have to connect a series capacitor. Connect a series capacitor. Clear, students? So these are the results we are having, and we are going to connect the device like that based on the situation. And what happens when the capacitor is connected in shunt, what happens when the capacitor is connected in series, and how to calculate the reactive powers, and what are the changes in power factors, all those things we have to see in detail, right? And I think you have understood the class very clearly, right? And that is the end of this class. Thank you for attending the class, right?
2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESE 2020 and ESE 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, Postal Study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now, 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course Mains Test Series and Interview Guidance Program in EASC 2020 and EASC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, Postal Study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESC 2021 from E&T branch. I took ACE Postal Course Mains Test Series and Interview Guidance Program in EASC 2020 and EASC 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation,